or this video, I'm going to talk about IO in terms of crowds and USD. Up until this point, we've been talking about we've been using the rig, Houdini rig, to set up our crowds, which is great. But we we may if your pipeline incorporates or uses USD, you may want to use your USD files on disk to set up your crowd sims. So this is what this topic will largely be covering. This is going to be split into two sections. The first section is going to be about taking a rig that's already in Houdini, in this case, mocap biped 3, and exporting it to USD so that we can use it in a crowd sim, because we need some USD agents on disk before we can use them and set up a sim. So that'll give us an opportunity to talk a little bit about USD and how it represents agents, and just kind of get you used to that. And then the second part will be us taking the USD that we've written to disk, bringing it back in, and setting up a crowd sim with that. I'm going to go through the process of creating the entire crowd sim. Because there are a few little gotchas here and there that I think are kind of important to see, I'm going to be going at a much faster pace than what I did when I was in the locomotion section. So, if you're kind of getting lost, go back to the locomotion section, review that, and then come back here, and you should be able to follow what I'm doing a little bit more. But I'm walking through I want to walk through the process and step by step, so that I'm not glossing over anything you need to do, and you have a full appreciation for what it is you have to do. Okay, great. Let's start with exporting this guy to USD. We're going to export a couple clips. Start off with this walk clip. I've changed this to walks and turns, and this is male R002. And let's just double check that this looks good. Yeah, and I've picked this clip because there's no popping at the midpoint. In the locomotion example, we were using a different clip and it popped in the middle, and I just don't want to have to deal with it for this example. So we can turn off in-place animation for this. There we go. Okay, so let's copy this. Alt, drag, and name it to run. And we should be in good shape. And great. So we got that going. And let's, in order to write this out to USD, there's a couple of steps we have to do. The first being that we need to turn the rig into an agent. And then the next one is we need to take that agent and import it into Solaris, which is Houdini's USD editor. So let's just go ahead and take care of that now. So I'm going to drop down a geometry node. And I'll drop down an agent node. And in this agent node, I'm going to point it to the walk rig. And I'm going to name the layer mocap biped. Great. And let's go down and take a look at the clip information. So walk, I'm going to use a specific frame range. Let's see, I believe this walk is what, 26 frames? Yeah, 26. So delete this, 26. And all right, we're in good shape. Everything looks good. Let's, I'll call this agent walk. And just to be very clear about what we're doing here, so this is now an agent. We can verify this by inspecting or getting the information about this guy. And you can see that we have one packed agent. Okay, so we've done that for the walk cycle. Let's alt-click and do this for the run. And we'll dive inside here. And we'll change this to run. You can also browse, but I find it's just easier to type sometimes. And we're going to rename the clip, not the default walk. We're going to use run, and this is only 17 frames. I know that because I've used it a bunch. Okay, so we now have agent run and agent walk, so we're in good shape there. I'm going to turn off the display for these guys. Good, and okay. All right, so then I'll just put these guys in a network box so we know that these guys are a distinct entity. So for export to Solaris. All right, so let's move over to Solaris and see about exporting this stuff to USD. So I'm going to go over here to my desktop, and I'm going to change it to the Solaris desktop, and that changes the layout. In this case, I'm still in the object context, even though the layout's changed. So I'm going to change this to the stage, which is basically where we do our USD editing. So we are now in Solaris or LOPS, and I'm going to hit tab, and we are going to drop down a SOP create. Okay, so a SOP create is basically like a little SOP network inside of LOPS, and you can go in here and do something like add a sphere. Perfect. And, but do modeling operations here if you want, but in our case, we're not going to do that. We are going to drop down an object merge and grab our agent from the other context. So let's go agent walk, grab that, and in it comes. And so we're in good shape there. I'll drop down a null, which is just kind of like a little placeholder, and I'll rename it to walk. Okay, and then I'm going to copy this. There we go, and I'll rename this run. I'm going to dive in here, and you guessed it, point it to the run agent. Okay, accept, and I get some sort of error. Not a big deal. Come back here, just want to check that I renamed this properly. Mocap biped. Okay, so we're in good shape. So let's go back to the stage. All right, so we're in good shape now. We have these two guys, the walk and the run cycle, they've both been imported into dots. Great. So the next thing I want to do is I want to set up a top network or a task operator network so I can write these guys to disk. So I'm going to come in here and I'm just going to drop down a USD ROP output, and I'm going to point it at walk. Great. I'm going to specify the frame range, 26 frames. Okay, fantastic. And I think we're in good shape there. So I'll rename this walk. You might want to save out your file and name it at this point, because the files are going to be named based on the HIP name, which is current name of the HIP file, and $SONOS, which is the name of the current node. So make sure you have your names done correctly. I'm going to drop down a merge and plug these two guys in. And so a top network can do any number of things. And one of the things it's very good at managing is dependencies of geometry caches and image renders and stuff like that, and managing what can be done in parallel and what has to be done in serial and what needs to run before something else. And in this case, we're doing something very simple, right? We're just sending two, agents to disk. Um, but you can imagine a scenario where you have something more complex and you have hundreds of agents that you need to write out to disk. You could very easily set up a bunch of Python and then, render this network, and it would render all or cache all of your agents to disk, all 100 agents to disk. And I'm just working on my local computer, but if you had access to a render farm that was running either Deadline or Tractor, which is Pixar's scheduler, or HQ, which is Side Effects' scheduler, it would basically you'd be able to run it in parallel on your farm. So useful in that respect. So anyways, in order to run these guys on disk, basically I'm just going to come over here and actually I'm just going to verify that I haven't written anything. Great. Okay. And then I can just execute this. So I can right click and go dirty and cook this node and ask you to save the file before going. And so this is basically caching out the walk and the run cycle as in two separate Houdini processes. So very handy stuff. Okay, so we've got these two guys cached to disk. I'm going to come back over into Lops or Solaris. And I'll drop down a sublayer node. And I'm going to grab the file that I'm looking for. So, all right, so I want the walk cycle, and we display it, and in it comes. I'm going to grab Control C and Control V, and let's do the run cycle over here. Okay. And I'll name this import walk, and I'll name this one import run. Okay, so yeah, this is great. Everything's working, and you can see that the information's coming in as we'd expect. So this is the walk. Did the run come in properly? No, I think okay, it's pointing at the right file. So is this pointing at the right agent? Maybe that's what I did wrong. It looks like that's pointing at the right agent. How about you? Yeah, that looks like it's pointing at the right place. So let's check this agent definition and see what I did wrong. Run character rig. Yep. Oh, and on the rig itself, I did not change it to. Whoops. I did not change it to. On the rig itself, I did not change it to still on walks and turns. So let me change that to runs. We should be back in good shape. All right, go back to my Solaris desktop, and it looks like I accidentally deleted a pane. So I kind of move some stuff around. And fair enough. Oh, I just collapsed it. Did I? There we go. Okay, so my apologies. All right, so let's go back to the stage, and now if we look at this guy, if everything is looking correct, he's still walking. So let's take a look in here. Yep, okay, let's go to the agent himself. And let's go to the actual rig. Okay, so looks like this agent's having a little trouble cooking for some reason. So let's just see if we can reload them. There we go. And everything seems to be working fine again. Okay, so with that, we just managed to fix that little problem. We can execute again. I'm going to right click on this run node, go delete this node's results from disk, which should delete the file. And then I'm going to rerun this, dirty and cookless nodes, and it'll reprocess. And with any luck, we should be in good shape. Okay, so come back over here, take a look. It's still the lock cycle, right? We need to reload. And now we see we have our agent running. So, okay, good stuff. Couple of notes. We managed to write our USD edge disk. A couple of things about what we're looking at. So over here we have the scene graph tree, which is basically showing us a tree view of our agent that we've written to USD and how it's basically structured in USD. You can see there's a lot of information here, including the animation. You have some nodes that have a primitive type called skell root, and there's skell animation and skeleton. And what this is all referring to is a schema inside of USD called USD skell, which basically defines how a skeleton and the animation that goes with it and the skin get written out to disk. So, one of the ways we can examine this, of course, if you've written out your USD to disk as ASCII, so if I put A here and write it out, you can just open a text editor and view it that way. Or you can, come onto this import node, and I'll just right click, go lop actions, inspect flatten stage. It'll take a second, and we can, take a look at what this USD information looks like. So we have a bunch of transform information being represented here, but you'll see some certain keywords that'll kind of, let you know that this is a USD skell or a crowd agent that's been written to disk. So yeah, let me scroll up here. Let's see. Yeah, so rel skell, this is, kind of giving you hints as to what's going on. Def skell animation. So this, gets into the weeds, and if you're an artist, you don't really need to be too concerned about this unless you want to be. But if you're somebody working in pipeline who happens to be watching this, you're probably very interested in this stuff. Regardless, I'm going to point you to a couple of resources that should help you out. So the first is Pixar's documentation on USD. You can find the one that's the description of USD skell here at this link. So that should be useful. And, it's got a kind of introduction to it. And one of the more useful things is it has this very simple example where it's just an arm that's been skinned. And it walks you through everything that you'd be looking at if you cracked open a USD file. So it's really, simple example where you can kind of digest what's going on. The other place you might look is over, they also have examples that you can download, and you can find them here. So, which are a little bit, more elaborate than just a deforming arm. And if you're just looking for some information generally on USD and Solaris and how they work together, there's this event that happened a little while ago called Houdini Hive. This was the one for Houdini 18. And the link is here, so you can just kind of look at that URL. And it was a multi-day event where they had a number of different workshops, and one of the days was dedicated to USD. And so if you take a look at these ones by, intro to USD concepts, asset preparation for Solaris, and layout of scene assembly. It'll kind of give you a bit, of an understanding of USD and a little bit of intuition as to how Solaris works with USD. That's a kind of good place to start. And if you're a pipeline guy, you probably want to take a look at Solaris and pipelines as well. My colleague Jeff Wagner did that talk. So lots of useful information there. Okay, so when we come back in the next video, we're going to take this USD information that we've written to disk, and we're going to work on setting that up for a crowd sim. Okay, we're back. In this file, we're going to be talking about. We've taken some rigs, some agents, and written them out to disk as USD. Now we're going to set up a sim using that USD we've written to disk. Right, so I'm going to change over from Solaris to the build desktop, and I'm going to switch from the stage to /obj. And this is where we did the setup for exporting these two different clips to Solaris. We can largely ignore that. And now we're going to go ahead and make a crowd sim. So let's come over here, and the first thing we're going to do is click on the agent shelf tool. And instead of picking a rig, we're going to come over here and pick USD. And I get a little error on my UI, not a problem. And I'm going to pick walk, hit accept. For the agent name, I'm going to call him mocap biped. And for the clip name, I'm going to call it walk and hit OK. Okay, great. So let's see what we got. Yeah, and we got nothing. So don't panic when this happens. This is okay. And I engineered this example so that this would happen. What you're seeing here is that we're reading in our USD file, and which is great, but there's this issue with this scale root primitive path. So let's open up this little browser and expand this and take a look at what we're looking at. Okay. So now let me close this one up. So there's this kind of tree structure here, and the way the setup works, the way the agent SOP works is it's looking for a primitive of type scale root, and you'll notice that there's a number of them in this USD file. So this is what we're looking at. We're looking at kind of this tree structure within the USD file. So the first one it comes across is this one, which is scale root, for this collision layer. And the collision layer is not the actual character skeleton. This is stuff that's being for that can be used for RBDs and ragdoll type stuff. So what we want is we want to grab this scale root and use that. And I'm just going to home the view, and now we see our character. This is very important, so it's a little important step to remember to do this. And if you don't, you can run into the problem that we had by default. Now, the thing to remember about this, and the gotcha here, is it looks for the first instance of scale root, or the first primitive of scale root that it can find. So if I'd named this agent, if I'd named the agent originally something like agent 1 instead of mocap biped, in that particular case, the scale root would be alphabetical, right? So it'd be ahead of the SOP create or ahead of this, and it would be the first scale root primitive that it sees, and it would get picked up and everything would work just fine. So it's one of these things where, if you're not aware of it, it could work fine the first few times and then it doesn't work and you're wondering why it doesn't work. So that's why I made a point of telling you about it and setting things up this way. Yeah, so Control Z, whatever. Just go back and grab it. OCAP biped, geometry, and we're in good shape. Cool. Okay, I'm going to convert to in-place animation because I want to do locomotion. I'm going to pick the hips as the root. Again, if this is strange to you, please go look at the locomotion videos that I made previously. Where is it? Right leg up to right leg. It's going to control orientation. And actually, I don't need to define this here. I'll do this somewhere else. I'll do this in the clip. My apologies. Okay, so we've got the agent set up. We see him here, and all of that's good. We didn't need to set this up here. We're going to do that on this agent clip node. Let's talk about setting that up. So I'm going to come back up here, and I'm going to click on this Add Clip option. And so once again, the first step was adding the agent. Now we're going to add the clip. This is why I wrote out 2 USD clips. And I'm going to go fetch run and hit accept and call it run. Okay, great. And then we come back inside and we're at load clips. So great. Same thing here. Let's double check this. So it's having trouble finding these 2 clips because we haven't provided with the appropriate skeleton primitive. So mocap biped, geometry, that should work, and do the same over here. Biped, geometry, and let's see what we get. There we go. So it also changed the default or the current clip to the last clip that we added, which is run. So I'm going to change this back to walk. We're in good shape. I'm going to convert this to in-place animation, and I'll do the same for the run. I get an error because I need to specify a locomotion node. So I grab a hip, and I grab the locomotion orient, which is going to be the right upper leg to right leg. And my error message is stop, and we should be in good shape. Okay, so this is great, one of the things I'll kind of mention here is there's a lot of like manual parameters and stuff like that you have to set up to get this, going correctly. This is a prime candidate for doing something with some Python script, right? Particularly if you have lots of clips, having some sort of Python script that can go through this and do this for you will be very, very handy. And the other thing I should mention, and if I haven't mentioned it before, a good like pipeline consideration is, these shelf buttons are doing discrete things, and the developers at Side Effects set them up this way because we're not making assumptions about how our users work. We don't know if you want to use, like, for example, locomotion or in-place animation. We don't know if you're using ragdoll or not. If you're not, you don't need these. Train foot planting. Is that something you want to use? Is it something you don't want to use? But my thinking is for most studios and artists and pipeline is you'll probably be doing the same thing over and over again for all your crowd sims, right? So if all 90% of what you do is crowd sims with locomotion and no ragdolls, there's no reason you can make a single shelf button that sets everything up for you, and you don't have to rely on all these discrete steps and doing what I'm showing you by hand. So, and as I said, the reason why we haven't done it for you is because each studio works differently. has a different way of representing data and has different needs. So we have the flexibility to accommodate all that. You just have to, write a little Python and streamline your process. But in the meantime, we're going to do it by hand. So, okay. The next thing that we're going to take care of here is the agent prep. And the agent prep operator, if you remember correctly, if you remember when we did this with, just using the rigs, right? mocap iPad 3 directly, all of this stuff got set up for you. And when you're using USD or FBX, that doesn't get set up for you automatically. The reason why it gets set up when you use a rig, some of it is because there's information in the rig, like capture regions and stuff like that, which we can exploit for information, and also just because we created the rig, we know what everything is named, so it's very easy for us to kind of create a default setup. So if you're doing this with USD, there's some extra steps that you have to do. So you got to create these torso and upper limbs and designate them. And this is to kind of get is particularly important for foot locking, because you need to have channels for the ankle and toe plant, and you need to know the simulation needs to know which bones it's going to do the foot planting with. So this is kind of what we start off with, and if we lower limbs at the moment, we just have 1 and 1. So I'm going to change this to 2 because we're going to have 2 sets of lower limbs, right? Right and left legs, and then I'm just going to go update the names of these bones that it's referring to, and feel free to skip ahead on the video if you'd like to. If you're following along, just go right ahead and follow along with me. And you can appreciate why a little scripting will go a long way here. And the other thing that I should mention is that you can create these parameters for a particular agent and get them set up the way you like. And then you can save a preset. So save presets, you save it and it becomes a preset that you can use to refer to and populate these fields, so you don't have to do it all by hand. And I'll do it for the upper arms as well, just to be kind of complete. And if memory serves, this is important for the ragdoll stuff. Okay, so looking pretty good there. Let's see. Head to head. Let me see if I'm... All right, so I think we're in pretty good shape. We need to create a foot plant chop network. So I'm going to click on that. It populates over here. And with any luck, we're in good shape. So come back, display out. And now I'm going to crowdsource. So I'm going to create a grid. Just nothing fancy. I'm going to hit the populate button, select the agent setup. Okay, so that's that node. Press enter, and it says select the terrain, which is my grid. Do that, bring the mouse back to the viewport and press enter. And there we go. Okay, so we now have our sim and it's populated. Great, and let's come back up here And I'll just move this crowd source over here. And the next thing we're going to do is we're going to simulate this. So let's drop down a simulate node, or the simulate button. Select crowd source to simulate and press enter. So enter. It asks for the different states. I'm not going to bother to do ragdoll. I'm just going to do the walk and the run. Hit accept. Groovy. We can come into the crowd sim. Looking good. Let's enable train foot planting. So I'm going to click on that, select the train object, the grid, and bring the cursor back to the viewport and hit enter. And there we go. I'm going to turn on a few other things like enable foot locking. I'm going to show the guide geometry, and I'm going to adjust the hips. And I'm going to change these states to locomotion. And hopefully we got what we need. So let's play this forward. And here we go. Great. So it's walking forward, which is fine, but you may notice it's doing something that's not so great. These heels are kind of sinking into the terrain. Okay, so why are these heels sinking into the terrain? Well, it's basically, we've specified the toe and the ankle for foot locking, but the ankle, isn't flush with the floor, and either is the toe, really. So we have to have offsets for this. So where do we define these offsets? Well, let's go back to our mocap biped setup. And let me hide other objects. And in the setup, there's this option here for ankle offsets. So, and you can kind of see where these offsets are. So what we need to do is offset the ankle, and this is what's used for foot locking to make sure that the foot is placed properly. I happen to have some values, so I'm just going to copy them and drop them in here. You could eyeball this, but for the sake of saving time, I'm just going to type in some values that I already figured out. And again, this is taken care of for you when you're using, the mocap biped 3 rig, because, it's Houdini's rig, and we know exactly. We created it, so we know exactly where everything's supposed to be. Saving this information in a preset, or having this information on disk somewhere and using a Python script to kind of roll through all the different values and set them would be super useful. So, all right. So there we go. Let's roll this back. The foot plant channels are, maybe not good anymore. So let's just delete this and we can recreate it. There we go. And looks like we're in good shape. Let's come back up here to crowdsource. Nope. We'll come up here to the crowd sim and reset simulation and dive inside it. And let's see if we get better behavior now. Yeah. So that looks much, much better. And just to verify that everything's working, let's drop down a trigger. And we'll trigger the change of state. Whoops. By time, we'll do seconds, we'll do 2, 0. Great. And we'll do a transition from walk to run. Okay, so let's see what we got. I'm not going to bother to make a clip transition graph just because I don't want to waste any more time. There we go. Yeah. What did I do wrong here? Ooh. Interesting. Let me go back and see if I can figure that out. Little issue there. Let's see. Load clips. Walk. Good. All right. Everything seems okay. Run. Okay. Rotate plus animation. Let's take a look at our agent. 17. This looks fine. All right, give me a minute and I'll get back to you. Okay, so we're back, and I've managed to figure out what the problem was. Basically, what's happening is, or what I did to kind of troubleshoot this and work backwards, right, is, okay, it's the run clip. We know that it's the run clip. There's this issue with it kind of popping back and then popping back. So what's causing that? Let's figure that out. Okay, so if we come back up here, basically the way I work when I find a problem is I like to work backwards. So there's nothing in the crowdsource about the clip length or anything like that. So that's not the culprit. Let's come back up to the mocap biped agent setup, and there's nothing in here that really kind of dictates the frame range. Okay, so what's the kind of next step in the chain? Well, we're reading this directly from USD, so let's look at the step before we wrote out to USD and see if we can figure out what the problem was. So I'm going to come back over here, go to the stage, and I will take a look at this guy. And let's take this is what got written out, and it looks fine, kind of, but we notice it goes once and then it flips back and starts again. And if we come over to the walk and look at the walk, let's see if it does the same thing. No, the walk doesn't do the same thing, right? It comes to the end and then it stops. So, okay, it kind of implies that there's something wrong with the run when we wrote it out to disk. So let's take a look and see if we can figure that out. And if we come over to the runs ROP USD output, we see that the frame range is set to 1 to 26. So, and I know that the frame range for the run cycle is only 17 frames. So this is most likely the culprit. This is probably what gave us the problem. So I'm going to right click and delete the results from disk. And then I'm going to dirty and cook the node again, which should write out the file to disk again. Okay, so let's come back to our operator here and take a look. And let's reload the file and see if anything's changed. Interesting. So, curious. Reload the file. And there we go. Now it looks, oh, no, still having problems. Okay, let me come back here. And I'll try once more, delete this node's results from disk. And I will dirty this node, do it explicitly, and dirty and cook this node. Save the file. For some reason, it doesn't look like it's rerunning, which it should be. So I'm just going to, I can solve this pretty easily by saving this out as under a different file name. So I'll call this run fixed. And if I dirty and cook this node, oh, let me escape out of this. I don't know what's going on. Delete this node's results from disk. Maybe this will work better. Interesting. Looks like there's a little bit of a bug here, but for some reason it thinks there's two work items here, which I'm not really sure why, but I will report that. And so now if we go back up to the stage, we're going to change this to run fixed, hit accept, and come back and take a look. And now you can see it's running, reaching the end of its clip and stopping. So we're in good shape. Let's go back over to here and come back to mocap biped setup. I will change this from run USD to run USD fixed. And hopefully that should be in good shape. For good measure, I'll just delete this chop network and recreate it. Good. And let's come back up to our sim, reset the simulation, dive inside it and see what we got. Yeah, and we've managed to fix our problem. So, but this is I've been trying to leave like the mistakes that I've made in here because if I'm making them, you're going to be making them too. So it's nice to know that these can be little gotchas. Anyways, so now we have a crowd sim, and it's exists in, you know, it's simulating. Let's work on getting this into writing this out, you know, as a completed crowd sim. Let's write it out to USD. So I'm going to drop down a null, and in that null, I'm just going to put sim out. Great. And we will go over to Solaris. And in here, I'll do something separate. I'm going to make a separate SOP create. So I'll put a network box around this so we know that those are all one thing, not related to what I'm doing over here. And over here, I'm going to drop down an object merge. And I will read in my crowd sim, crowd source, sim out, right? And we can play this back, right? So by default, this crowd sim being sourced, and we'll display it over here. By default, LOPS will load one frame at a time, and you know, more than likely when you want to cache this sim, you might want to cache it to a single file rather than per frame. And to do that, I'm just going to drop down a cache, and this basically will ensure that all the animation gets saved into one single file, and you get to specify the frames. Okay, and then I'm going to drop down a null and say out crowd sim. And once again, I will create a top network, USD ROP output, frame range. By default, it puts everything in a single file, and I'll point the LOP path to out crowd sim. Great. Want to have initialize simulation op turned on because I'm writing out a simulation. And I want to turn on all frames in one batch to ensure that everything gets run in sequence. It's going to name it using the current HIP file. So current HIP file's name as well as the name of this node. So I'm going to save this as under a different file name. 5.2 USD Setup sim. Okay, and yeah, let's execute this. So cook selected node, and I'll start running the sim. And you should see it writes out fairly quickly. It's going to take a minute on that first frame to get that instance of Houdini running. It needs to start up a new instance of Houdini before it starts running. And I'll see you once this is done. Okay, our sim is finished and it's now cached to disk. Let's go read it in and see what we got. So I'm going to drop down a sublayer and click on the display flag and go grab the file from disk. So there we go. Hit accept. Oops. And we can play this forward. And there we go. There's our crowd sim. So one last kind of note in terms of setting this up and executing it and running it. When we created the agent, there was an option to look at a LOP network instead of a USD file. So this is still a perfectly legitimate way of working, but instead of reading the USD directly from disk, you can read it from a LOP network. Reasons why you may want to do this is you may want to make some sort of edit to your agents when you read them in. So you may want to read this guy in and do some sort of edit. You'd be able to do that in LOPS, and then after whatever edit you've made has been complete at the end of that chain, you can just refer to that and then read it in, read those in over here. And we can actually give that a try while we're here. So just come up to agent create. I'm going to change this to, oh, do I really not have an option to LOP network character rig? Ah, interesting. So file LOP, there we go, USD LOP. And this is the walk clip. So I'll go stage, import walk, and everything looks good. Let's do the same thing over here. I'm going to change this to lop and this to lop, and I'll have the walk look at the import walk node, and I'll have the run look at the import run node, and everything should be nice and kosher. Let's come back up to this .NET reset to sim, play forward, and everything works as expected. So yeah, this is that concludes I/O for USD. I'm going to do another one on FBX, so you can take a look at that as well if that interests you. Thank you, and I'll see you in the next video.